DevOps and CI-CD Part 7. This episode has 14 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Docker troubleshooting. A container works locally but fails in Kubernetes. How would you debug entry point, environment variables, file system, permissions, and health checks? Here's a strong way to approach it. Start with kubectl describe pod and kubectl logs to see the exit reason and any startup errors. Then check that all required environment variables or config maps or secrets are actually mounted in the pod spec. A common gap between local Docker run and a Kubernetes manifest. Verify the entry point command matches what Kubernetes expects. No interactive TDY assumptions. Check file system permissions if the container runs as non-root or with a read-only root file system. And confirm readiness or liveness probe paths and ports match what the app actually exposes. Nice. Let's continue. Question 2. Docker networking. How does container networking work locally, and what changes when the container runs in Kubernetes? Here's a strong way to approach it. Locally, Docker creates a bridge network where containers get an internal IP and communicate via container name, Docker DNS or published host ports. In Kubernetes, each pod gets its own IP on the cluster's pod network, via CNI, and service objects provide a stable virtual IP and DNS name that load balances across pod replicas, replacing Docker's single-host bridge model with a cluster-wide overlay or routed network plus kubeproxy or EBP-based service routing. Great, moving on. Question 3. Docker volumes. When would you use bind mounts, volumes, or ephemeral container storage? Here's a strong way to approach it. Use bind mounts for local development to live sync source code into a container. Use named Docker volumes, or in Kubernetes, persistent volumes, for data that must survive container restarts and be managed independently of the container lifecycle, like database files. Use ephemeral container storage, the writable layer or empty dir in Kubernetes, for temporary scratch space that is fine to lose when the container restarts. Alright. Next question. Question 4. Docker Compose. When is Docker Compose useful, and why is it different from Kubernetes? Here's a strong way to approach it. Docker Compose is ideal for local development and simple single-host setups where you want to define and run a small set of interdependent containers, app, database, cache, with one command and minimal ceremony. Kubernetes is designed for multi-host production orchestration, scheduling, self-healing, rolling updates, service discovery across nodes, autoscaling, which Compose does not provide. Teams typically use Compose for local dev or test and Kubernetes for staging or production. Let's keep going. Question 5. Docker production readiness. What checks should pass before a Docker image is approved for production? Here's a strong way to approach it. The image should be built from a pinned, scanned base image with no critical or high vulnerabilities. Run as a non-root user, have a minimal attack surface, no unnecessary packages or shells in distroless-style images, and define correct health check or Kubernetes probe endpoints. It should also be built reproducibly from CI, not a developer laptop, signed or attested for provenance, and tagged immutably so the exact artifact tested in staging is the one deployed to production. On to the next one. Question 6. Scenario. Registry outage during deploy. Your container registry becomes unreachable mid-deployment and half the pods are on the new image, half on the old. How do you stabilize the rollout? Here's a strong way to approach it. Pause the rollout rather than retrying blindly. Kubernetes will keep trying to pull the new image for pods it hasn't scheduled yet, which just produces image pull back off noise while the registry is down. Check whether the already running new version pods are healthy. If so, hold the mixed state. Most services tolerate a brief mixed version window, until the registry recovers, then resume the rollout, or roll back to the old image tag if the mixed state is causing user-facing issues and the old image is still cached or pullable. Afterward, add a registry mirror or pull-through cache so a single registry outage can't stall production deployments again. Good, here's another one. Question 7. Scenario. Poisoned base image. A base image your Docker files depend on was found to contain a vulnerable package after being in production for weeks. How do you respond? Here's a strong way to approach it. Identify every image built from that base by scanning your registry or CI history for the base image digest, not just the tag, since a floating tag may have already moved. Rebuild and redeploy affected services from a patched base image, prioritizing internet-facing services first, and treat this as validation for pinning base images by digest rather than tag going forward so you always know exactly what's deployed. Add automated scanning on a schedule, not just at build time, so a newly disclosed CVE in an already deployed image is caught within hours instead of being discovered weeks later. Nice. Let's continue. Question 8. Ansible inventory. How would you structure dynamic inventory for GCP, AWS, and Azure instances instead of maintaining a static inventory file? Here's a strong way to approach it. Use Ansible's dynamic inventory plugins, GCP Compute, OSEC2, Azure RM configured with tag-based or label-based grouping, so hosts are discovered live from each cloud API instead of hand-maintained in an ini file that drifts from reality. Cache inventory results with a short TTL to avoid hammering cloud APIs on every run, and group hosts by environment or role tags so playbooks can target env prod, and role web style selectors consistently across clouds. Great. Moving on. Question 9. Ansible error handling. How do you handle partial failures in a multi-host Ansible run so one bad host doesn't block the rest of the fleet? Here's a strong way to approach it. By default, Ansible removes a failed host from the current play but continues on the rest of the fleet. Use max fail percentage or any errors fatal, false to control how much failure is tolerated before aborting the whole run, and ignore errors, true sparingly for genuinely non-critical tasks. Always review the retry file Ansible generates, retry or a summary report at the end so failed hosts are remediated deliberately rather than silently skipped. Alright, next question. Question 10. Ansible Jinja 2 templating. How would you use Jinja 2 templates in Ansible to generate environment-specific configuration files safely? Here's a strong way to approach it. Use the template module with .j2 files that reference group vars or host vars for environment-specific values, keeping secrets out of templates by referencing Ansible Vault encrypted variables instead of hard-coding them. Validate rendered output with check diff before applying, and use Jinja 2 filters and default guards defensively so a missing variable fails loudly in CI rather than rendering a broken config silently in production. Let's keep going. Question 11. Ansible Tower or AWX. What does Ansible Tower or AWX add on top of plain Ansible playbook for enterprise teams, such as RBAC, scheduling, and audit logging? Here's a strong way to approach it. Tower or AWX adds a web UI and REST API for launching and scheduling playbook runs. RBAC so only authorized teams can run specific job templates against specific inventories. Credential management that keeps SSH keys and secrets out of individual laptops, and a full audit trail of who ran what, when, and with what result. It also supports workflow templates that chain multiple playbooks with approval gates, which plain Ansible playbook has no concept of. On to the next one. Question 12. Ansible OS patching. How would you design a safe, automated OS patching workflow with Ansible that includes health checks, rolling batches, and rollback? Here's a strong way to approach it. Use serial in the playbook to patch hosts in small rolling batches, e.g. 10% at a time, with a health check task after each batch that verifies the service is healthy before proceeding to the next batch. Snapshot or take a backup before patching so a bad patch can be rolled back, and gate the run behind a pre-check task that confirms the host is drained from the load balancer first so patching does not cause user-facing errors. Good. Here's another one. Question 13. Ansible linting. How would you enforce Ansible code quality using Ansible lint, pre-commit hooks, and code review before merging playbook changes? Here's a strong way to approach it. Run Ansible lint and yamlint as a pre-commit hook and again in CISO style and common mistake rules. Missing handlers, hard-coded credentials, deprecated syntax, are caught before merge, not at runtime against production. Require a syntax check and check diff dry run in the PR pipeline, and mandate human review for any playbook touching production inventory groups. with the diff clearly showing which hosts and tasks will be affected. Nice. Let's continue. Question 14. Ansible secrets in CI or CD. How would you securely supply an Ansible vault password or SSH key to a CI or CD pipeline without hard-coding it? Here's a strong way to approach it. Store the vault password and SSH private key in the CI system secrets store, GitHub Actions secrets, GitLab CI variables, and inject them at runtime as masked environment variables or a temporary file created only for the job's duration, never committed to the repo. Prefer a vault password file supplied via vault password file pointing at a runtime generated path, and rotate the vault password and keys periodically, especially after any CI credential exposure. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.